Hi, this is Paul Neale at Penn Productions, and in this session we're going to work on creating an MCG Wave Modifier. So max creation graph, just quickly cover what that is. If we have a look here, we've got a new graph, open graph, and just max creation graph. So we'll just open that quickly. You can see a graph currently open in front of you here. This is a spline operation tool. We have another one here that's a wave, and we're going to try and replicate some of this anyways in this tutorial to get it going. But essentially what max creation graph is a node-based programming method where we can tie together nodes and generate plugins, actual plugins, not just tying together nodes within the system, but actually generating new plugins, modifiers, tools, functions for max script, splines, controllers, geometry, and all sorts of other things. This is a default layout here. We got a couple of areas to take a look at. One is all down the side. We've got all kinds of different nodes that we can drag out and use. We can also search at the top. We can also hit X just like we would in other areas of Max to be able to search for them and find what we're looking for. Down at the bottom we have a reference, so when you pick any one of them, it will actually give you a little bit of a breakdown of what it's supposed to do. And then we have a message log that's going to be reviewing and telling us what's happening as we're doing it. Error messages, whether or not we succeeded in creating something that actually functions. I like just pulling this around a bit more. I'm going to get it a little bit out of my way, and I'm going to drop that one down there so that they're out of my way a bit more, and I've got more area to work in. So we're going to create a modifier that turns a plane into a wave and get the wave going. So first what you need to know is you need some sort of output. So you have to determine what the output is going to be. Let's scroll down here and we can find outputs. And as outputs, we have a number of different solutions here. If you're working in Max 2016, you'll find that there's not as many. This is 2017, and now there's a lot of other options here, and most of them come in the case of the animation controllers from the different types of controllers. But we also have a modifier and utility and shape and geometry. And there's also compounds, and we'll get into compounds later as to what they are and how they function. But they can be of great help in cleaning up your flows and sort of producing reusable tool sets. We're going to start with a modifier, so I'm just going to drag this out. So this is going to actually generate a modifier for us. Now we need some sort of input into this, and if you drag out from the input into the end, what it'll do is it'll give you all the possible things that can then be input into here, and we can start searching in here. So if I type in mesh, you can see that it brings us a whole bunch of different options, or modifier tri-mesh. And this is what we're looking for right now, is modifier tri-mesh. And so modifier tri-mesh is essentially the input mesh that's coming up the stack from below it in the stack. And what we've just done is we've created our first modifier. Let's save that. I'm just going to say save. And we could save it into the max creation graph, so under Max 2017, where you've installed it, max creation graph tools, or Max 2016, whatever it might be. And we're just going to say MCG underscore test, and we're just going to drop in a test modifier. This will evaluate next time Max loads so that it's actually running. Now we've got the feedback area here, so it tells us we've saved it, and now we want to evaluate it. So if we go to Build, Evaluate, you'll notice it's Control E. This is the same hotkey as in MaxScript, so Control E will execute it and get it up and running. So you'll see successfully evaluated. Now if we restarted Max, it would automatically reevaluate itself on start and already be there. So let's take a look at this. I want to pop out of here, just go and grab a plane object. And I'll just put a big plane down and just zero it out for now. And let's give it some segments along the length of it so we can start seeing what the results are and how it's going to work. So in the modifier stack now, it'll be named the same thing that we named the actual and saved the tool as. So we got MCG Test Modifier. So here's the MCG Test Modifier, and currently right now it's a modifier that does absolutely nothing whatsoever. We have a parameters rollout here, but there's no parameters in it. It doesn't do anything at all. It has no functionality at this point. So if we reopen it, now I've set a hotkey for that to open this, and we can start working on what's going to happen in here. Now the interesting thing about dealing with the modifier here is we're going to have to get into functions right away and understand how they work and what they do. So if you don't know what a function is, let's discuss that really quick, and let's see what that's going to do for us. Let's take a look at that in terms of McScript and what it is in McScript if you're not aware what a function is. So a function in any programming language would usually start off with the word function. Now in McScript you'll often see the short form just fn. We give the function a name, and then we can give the function some inputs to say, well, let's pass this some information, and we're just going to call this val equals, and I'll then finish our function off. If I evaluate this, I'll just open up the listener and clear it with Control D. Just make it bigger so you can see, and evaluate again, Control E. You'll see that it evaluates out a function. I can call the function by saying test, open close parentheses, and it won't pass any values, and this is going to throw an error for us right away because it's requiring us to pass a value of some kind. I want to pass that value as just 10, let's say, and then I'm going to run that again, and you'll see that it comes back as undefined. Effectively, this just ran this function. It called test, which is the name of our function. It passed the value 10 to the word value, and let's do something with it. Let's go 20 plus val, and that'll return out of the function now. So I'm going to evaluate just the function, for instance, with Shift Enter, and then if I run this last line, you'll see 30 comes back to us. That's because it's actually producing this. So what if this was an array of things? What if it was a bunch of things that were being passed to it, and we had 10, 20, 30, for instance? Now this is an array in McScript, so it is a collection of things. So val is going to become equal to those, and we're going to have a function that loops through those. So we're going to say for x in val do, and this time I'm just going to use a print statement so you can see it because it's not going to be returning from the function. Print, and we're going to say x plus 20, and again I'll evaluate my function. You can see it comes back with test. We'll pass the array this time. We get back 20, 30, 40, 30, 40, 50. So what's happened is this function has gone through this array that we're passing it, which represented here, and then as the name val, and it runs through it, and for each one of the things in the array, it adds 10 to it and prints it out. Or 20 to it, sorry, and prints it out. So with that little bit of knowledge, let's go back and take a look at what the max creation graph is going to have to do. In this tri-mesh, we've got a bunch of vertices, and we're going to have to process those vertices and get those vertices to return a new value. So we're going to have to push them into a new position for us at that point in time. So what we need to do now is we need to from the tri-mesh, we need to get the vertices. So we're going to say mesh, and just down at the bottom, we're going to find mesh vertices. So the mesh vertices are the actual vertices, the positions of the vertices, effectively. We can then pipe that into a set vertices, and we'll find that by typing it in as the set mesh vertices. And we're going to set that mesh vertices, and it's also going to need the mesh. So it's going to need the actual mesh that we're going to set the vertices on, and then we'll pipe that back in. So again, we now have a more complex, and we'll check it again, it'll evaluate. This is a more complex version of the previous modifier. It doesn't do anything at all. So if we check it, we can still see there's no parameters or whatnot, and it still has no effect on the actual mesh. So what we need to do now is in between here, where the mesh vertices and the set mesh vertices are, is we need to transform the mesh vertices at this point in the node hierarchy. So to do that, we're going to have to use something called a map. And here's another way to go and get your nodes. Then I'm going to hit X and type in map. And there's a bunch of different solutions with map, by the way. You can also type in star map and map star, however you want to do your wildcard. So I'm going to use a map. And we can connect and disconnect as well. So if you hold down the node, start moving it, and hold down Control and slide it over top, it'll automatically connect it. And if there's multiple connection points, it'll ask you where you want to connect it to. You can disconnect by moving it and holding down Alt. This is exactly the same as the Slate Material Editor. And you can move entire hierarchies using the hotkey Control and Alt. Again, just like in the Slate Material Editor. So I'm going to drop that back on there. And so what we're going to be doing is we're going to be taking the tri-mesh, breaking out the vertices, pumping that into a map, and I'll explain this one in a second, setting the result of the map into the set mesh vertices on the actual mesh, and then piping out the final resulting mesh from that. The map vertices then has a function input, as you can notice. So what this map essentially does is what our array was doing. And so I'll just go back to the editor. Essentially our map is doing this portion here. It's looping through and it's going to apply a function to it. So it's kind of like having a function with that loop built in. So this function here is going to be our function. And it's going to take an input, and that input in this case is going to be the mesh vertices coming into it. So it's going to be whatever these vertices. So it's exactly the same as when we called and passed in this array. The mesh vertices will be that array that's getting passed into the function. So now what we want to do is we want to start building this array. So what we need first is something called a pass-through. Now a pass-through node allows us to be able to get those values and pass them through to the rest of the functions that we're going to be using. So we're going to be looking for a vector3 pass-through. So this vector3 is going to be the vector of each one. So if we were to consider how this works now, the pass-through is going to, I should explain, the vertices are coming in from the mesh vertices. They're being passed into the pass-through, and then we're outputting the function that's going to do the work. So once again, this should evaluate successfully as it is, but again, it still does nothing whatsoever. So we need to start breaking this up. I'm going to grab this line and just delete it. And we're going to break this off and start doing some bit of work to be able to get this to work. First off, let's break this up into our individual pieces so we have our individual X, Y, and Z channels that we can work with. To do that, we're going to grab the X, and this will give us our X and our Y and our Z. And there's our individual channels that we can now do work with. So to get this to work and do what we're looking for, right now this is the X moving along the length of the plane. We're going to use the position in X to drive the position in Z up and down with a wave. So as the value gets larger going up the X, for instance, we're going to pipe that into a sine curve, and that sine is then going to make the wave happen for us and make it go up and down. So with this coming in, our vertices coming in, we're going to break them off. We're going to start doing some work on these. So we're going to need the sine of the X. So I'm going to drag out and I'll type in sine, and we'll get our sine curve. So we're going to drive our sine curve with the value moving along its length. And we need to add that, so I'm going to go and pick add, and I want to put that into the X. So you'll see it actually asks you when there's multiple inputs. And I'm going to add the sine of X to Z, which is going to be our position up and down. And then we have to come up with a final 0.3. So we need to actually make sure that the data type's the same. So the mesh vertices is outputting a vector3. We're going to have to bring a function in that's a vector3 as well. So I'm just going to pull out and say vector3, and we're going to pipe this into the Z. So this is going to be the Z, the final Z solution. So we're going to use the sine of the X and add it to the Z to get our Z. And then of course we need the X and we need the Y to complete the vector3. Now we don't use the final output. This is the final value. We want to say this is indeed going to be used. This is indeed going to be used as a function, and we want to take this input and pipe it through. So we're going to take the function output and pipe it into the function of the map and say that this map is going to use all of this math right here as our function. It's going to take the mesh vertices, it's going to put them into the pass-through vector 3, break it into its part, do the math on it, and then output the final solution. So I'm going to save that, check and make sure that it evaluates again, and then we can go and see that our plane now has actually got a ripple in it. And we can start doing some more math and start playing around with the values so we can control that with those values. So let's do that and start working with some of this. So again, we want to start playing around with the sign and the values of them, and where we're going to be multiplying in some of the values. So let's get some controls now so that we can use these as a UI. So we want some spinners in the UI. And there are a couple of things you're going to find. There's outputs, and then there's the inputs, and you'll find a bunch of inputs here. These are not what you're looking for. You want to find parameters, and you want to be using parameters for those. So if we look down, there's a bunch of different parameter types, and parameters become UI items that we can use. In this case, we're going to be looking for singles. We drag one of these out, and it's going to ask us for a couple things. So what we're going to say here is amplitude, frequency. So we got amplitude and frequency, and then we can start using those as well. So our amplitude, you can set min-max values, system units if you like, so you can have your different value types. We'll come back to these and set these up. Once these are piped into the flow, we'll see that we can actually work with these values in the final modifier. So now we're going to tie in the amplitude. So to tie in the amplitude, we want to multiply after the sign. So let's get a multiply node, and I want to drop that in. This is X and then M, and we can easily find the multiply in here. Maybe just multiply. And I'm going to hold down the control again and drop it on the line and pipe it into the Y at the bottom, just because it kind of makes sense to bring this down and in. So there's our multiply coming in of our amplitude value. And now we're going to multiply that in. So let's just save, evaluate, make sure that it evaluates again. I'll close this down, and we'll see now that the amplitude is being pushed up. So we can increase the amplitude of the wave. I'll just go down and I'll just increase the amount of segments along the length of it here to smooth it out a bit. And we can see that the amplitude's being pushed up. Okay, so let's go back to the MCG graph and go in and put in the frequency. So the frequency comes before the sign. So same thing, I want to grab the multiply, but this time I'm just going to hold down Shift and copy it, hold down Control and drop it on and connect that in, and then connect in our frequency value and save and evaluate. So it evaluates again, and I'll close it so we can see what's going on. If I push up the amplitude, nothing happens. It's because our frequency is currently set to 0, and we can now control both of those. So we can control the amplitude and we can control the frequency to be able to get our waveforms happening. Now you might want to invert this and call it something other than frequency. Frequency means it's going to get more frequent as we turn it up. Sometimes I like to use simpler sort of non-mathematical terms like wavelength. And if we're going to use wavelength, we'd want to do some inverting and a little bit of work on it. So I'm just going to pull all this down, and I'm going to drop in two more. Constant and a divide. So the constant value can be anything you want. Now what you need to make sure is that if we're pumping in a float value here, as we have with our single, parameter single, we need to make sure this is a float value. So I'm going to say 1.0. If I put 1 and then piped it in, it would complain to us that it had types that weren't the same trying to be worked together. So I want to say put that in there and that in there. So now that we're going to divide our output by a constant of 1, and I want to take the output of it and put it into our multiply. Evaluate it again, and what you'll see now is as this becomes turned up, it'll be the wavelength effectively. So we can make the wavelength longer, and we have our amplitude now that we can manipulate and work with. So there's essentially a really simple waveform going already. Let's get it moving automatically with time, and let's pipe in some time and work with that value so that it'll actually automatically ripple and wave across the form. So now we're going to need some time functions. So I want to say x star time and time int, and this is going to output a time for us. We want to convert this over to seconds now, so I'm going to go and put this in and say ticks, because that's what it comes back in, and say ticks to seconds, so that we're working in seconds at this point in our timeline. And we can output now a time value and work with that. So we're going to want to have another input value. So I'm going to grab our inputs again, and let's just pull this down here. And this one is going to be called speed. And we want to multiply these two together. And so that we can increase or decrease the speed by multiplying the seconds. So now we're going to take the solution here, and we're going to add it to the x. So we're going to go and grab the x value now, and so we need an add, and I'll pipe that into the bottom, taking the final solution. So we're going to take the output of the add, pump it into the multiply, so that it pipes down through to the final result. Let's check that. Evaluated successfully. We should have our waveform now. If I hit animation to start and then start turning up the speed, you can see that the speed now controls the waveform and gets it rolling along the shape. So this is a good example of working with MCG for developing modifiers for deforming meshes. Hope you enjoyed that.